Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. Didoakan kepada semua pelajar dan pengunjung Syahnun Channel dalam keadaan sihat dan diberikan rezeki yang berlimpah ruah. Video pada hari ini ialah VSEPR Theory. Diharapkan semua mendapat manfaat. Mari kita saksikan. Hello everybody, our topic today is about molecular geometry, the shapes of molecules. Determining the shape of a molecule, Lewis structures don't give us a three-dimensional view of how the atoms are bonded together, like what we see in the picture. The carbon tetrachloride there, the Lewis structure imply a cross shape with 90-degree angle, but actually the real shape of carbon tetrachloride is tetrahedral with the angle is 1 or 9.5. So how do we find the shape of molecule? We will use VSEPR theory. We call it VSEPRs. Okay, VSEPR theory, valence electron pair repulsion theory. The basic principle is each group of valence electrons around a central atom is located as far away as possible from the others in order to minimize repulsions. And the strength of repulsion, lone pair versus lone pair, stronger than lone pair versus bonding pair, stronger than bonding pair versus bonding pair. Okay. The symbol that we will use is AXE. A is central atom, X is surrounding atoms, and E is non-bonding electron. Usually we call it a lone pair. Okay, here is the 5 main VSEPR shapes. Number 1 is linear, the second one is trigonal planar, the third one tetrahedral, the fourth is trigonal bipyramidal, and the last one is octahedral. As we can see in the picture, the shape of molecule is represented by a balloon analogy, a balloon model, and also ball and sticks model. Okay, and each molecule has its angle. For example, for trigonal planar, all the angle from terminal to center and terminal is 120 degree. For tetrahedral, for example, all the angle is 109.5 degree. And for trigonal bipyramidal, as we can see, is combination from trigonal planar and linear, and the angle is 120 and 90. For the octahedral, is all the angle is 90 degree. For linear arrangement, it has one center atom and 2 terminal atoms, so the symbol is AX2 without lone pair. Okay, the angle for this molecule is 100 degree. An example is CS2, HCN, and BeF2. For trigonal planar, we have one central atom and 3 terminal atoms, so the symbol is AX3 and the shape is trigonal planar. The angle is 120 degree. Okay, an example for this molecule is SO3, CO3 and it has one derivative when we remove one atoms and replace by one lone pair. So now the shape is bands or V shapes. Okay, the angle of molecule is not 120 degree but less than it, because the lone pair repulses the bonding pair, and the shape is band or V shape and angle less than 120 degree. The symbol is AX2E. Alright, we go to the tetrahedral. Angle for this tetrahedral is 109.5. The symbol is AX4. An example is CH4, SiCl4, SO4 to minus. And one of its derivative is AX3E. And the shape is trigonal pyramidal. It has one lone pair, as we can see. And the other one is bands of V shapes. The symbol is AX2E2. As we can see, it has two lone pair, okay, and two bonding pair, or two terminal atoms. Alright, we go to the trigonal bipyramidal. Trigonal bipyramidal, it has two angles, 90 degree and 120 degree. Okay, if you remove one of the terminal atoms, it becomes seesaws, okay, seesaws or distorted tetrahedral. Okay, example is F4, XeO2, F2. The second one is T-shapes. T-shape, we remove two terminal atoms, and now it has two lone pair. The symbol is AX3E2. Okay, example ClF3. And the third one, derivative of trigonal bipyramidal is linear. Okay, three lone pairs. Now the symbol is AX2E3. Alright, the last one is octahedral. It has 6 terminal atoms. The symbol is AX6. And if we remove one of the terminal atom, replaced by one lone pair, now it becomes square pyramidal. And the second one of derivative is square planar. We remove two terminal atoms and it has two lone pair. Okay, how we want change from Lewis to VSEPR shapes? Number one, we have to draw a Lewis structure. You have to master to draw the Lewis structure first. Okay, the second one is count the number of electron domains. What is electron domains? Electron domains is single bond, double bond, or triple bond. We count as one domain. And lone pair, we count as one domain. Okay, this is what we call electron domain. And then we will use VSEPR theory to determine the shape based on how many bonding and non-bonding domain are around the central atom. Alright, okay, here we have a problem. Draw the molecular shape and predict the bond angles relative to the ideal bond angle of A PF3 and B COCl2. You can refer to my previous video how to draw the Lewis structure, and this is given in the description. Here is the Lewis structure of PF3. Alright, as you can see, the center is phosphorus, and we have 3 terminal of fluorine, and it has 3 bonding pair. Okay, BP is bonding pair, P with 3F, so 3 bonding pair, and 1 lone pair. Okay, 1 lone pair. If we total, it's become 4, and 4 is electron domain. Molecules with 4 electron domain, if we refer, it is tetrahedral arrangement. Tetrahedral arrangement. The shape of electron domain is tetrahedral arrangement, but this is not the real shape, you know, not the real shape, because we have to look at the symbol AX3E. Okay, AX3E is it is a derivative of tetrahedral arrangement, and for AX3E the shape is trigonal pyramidal. Okay, trigonal pyramidal. Okay, this is the final shape, trigonal pyramidal. Okay, this is how we want to draw the shape. P, phosphorus, and 1 lone pair, and the F is like this, So now it is the shape is exactly trigonal pyramidal. All right, and then we can put the lone pair for the fluorine. Okay, so this is how we solve this problem. Okay, this is the real shape ball and stick model. All right. Okay, we go to the COCl2, and this is the Lewis structure. It has one double bond with O and single bond with Cl and Cl. So the BP equal to 3, the bonding pair, as I mentioned earlier, double bond consider is 1, and 0 lone pair. So electron domain is 3. So the shape is based on the trigonal planar, right? And the symbol is AX3 without E, so the final shape also trigonal planar. Okay. Alright, we go to the third problem, BRF5. Okay, the first step is draw the Lewis structure. As we know that bromine is 7's valence electron, fluorine also 7's, and the Lewis structure is like this. Bromine has 5 bonding with fluorines and 1 lone pair, so the BP bonding pair is 5, okay, and lone pair is 1. Electron domain is 6. So for the 6 electron domain, we refer to the octahedral arrangement, and the symbol is AX5E. The final shapes is square pyramidal. Okay, now we try to draw the square pyramidal. Okay, bromines, and then bonding with fluorine and 1 lone pair, and the 4 bromine in a planar arrangement. Okay, the angle is 90 degree, and then here is the planar, and then if we draw the line between F and F and F and F, we can see the shape is square pyramidal. Alright, now we come to the conclusion or tips. Number 1, you have to master a Lewis structure. If you write a Lewis structure wrongly, of course you will predict the wrong shape of molecule. Number 2 is number of electron domains. The number of electron domains range from 2 to 6, right? If we have 2, that means the molecule is linear, and 6, of course the shape is octahedral. Number 3 is molecules without lone pair. If the molecule without lone pair, of course they are in a 5 basic shape. Alright, the molecule must be in 5 basic shape, whether it is linear, tetrahedral, octahedral, and so on. And number 4 is molecule with lone pair. This is derivative of VSEPR's shape. Okay, for example, we have molecule with 3 electron domains. Okay, so the basic shape is trigonal planar, and for example it has 1 lone pair, so the shape is band. Okay, that's all for today. Have a nice day.